Hello, this is 10.8 geometric probability. Probability is equal to your favorable outcome and your sample space. Another way of looking at it is your specific thing over your total amount. All right, favorable outcomes. What do you want? So what are you looking for? And then your sample space is your sample space, your total amount that you have. All right, so a dice, this is important. Probability is always a fraction between 0 and 1. And if you're doing it as a percent, then it's between 0 and 100. So it's a fraction between 0 and 1. If you have something over 1, then you did something wrong. A dice is tossed. Dice has six sides. What is the probability of getting each of the following events? Rolling an even number. So what are your even numbers? 2, 4, and 6. So 3 out of the total amount, which is 6 sides. So that's going to equal 1/2. Rolling a number divisible by 3. So 3 will go into 3 and 6 will go into 3. So 2 out of 6. So your answer is 1/3. Rolling a number less than 6. So 1, 2, 3, 4, and 5. So 5 out of 6. And that's your answer. What is the probability that a fly lands on a point between 2 and 10? So here's 10, here's 2. So 1, 2, 3, 4, 5, 6, 7. And see, the total is going to be 11. Is your sample space. And again, we said 7, I think. 1, 2, 3, 4, 5, 6, 7. Again, it's asking for points here. So 7 out of 11 is your probability. What is the probability that a fly lands on a point between 3 and 7? Between 3 and 7. So 1, 2, 3. So 3 out of 11. The total amount is 11. A point on AB is selected at random. What is the probability that the point is on CD? All right, so your total sample space is 10, is your sample space. And CD, from C to D, 1, 2, 3, 4. So 4 out of 10. CD is equal to 4. So 4 out of 10 gives you 2 out of 5. All right. Find the probability that a dart lands randomly inside the square. So that means in here. Inside the square, but not in circles. So this part right in here. All right, so find the area of a square. So the total is going to be 20 by 20, which equals 400. And then the circle, find the area of the circle, and that's going to be pi times r times r. This one up here is base times height are your formulas. So 10, because the diameter all the way across is 20, so 10 times 10 times 3.14. And that's going to equal 314, 100 times 3.14. So you're going to take the 400 and subtract the 314 and get 86. So all of this, all four of these are 86. So 86 divided by the total amount, which is 400. And when you do that, you get 0.215. So 21.5% is not in the circle, but on the square. Find the probability that a dart lands randomly inside the square, but not on the circle. So same thing again, but this is at 10 inches. So the total is 10 times 10, which is 100. And the circle is going to be 5 now for the radius. So 5 times 5 times 3.14. And when you do that, you get 78.5. And subtract that from 100 will leave you with 21.5. And so 21.5 divided by 100 is going to give you 21.5%. And find the probability that a dart lands in. Okay, so this is 4 feet. So 4 by 4. And we'll give you 16. And the circle is going to be 2 times 2 times 3.14, which is going to equal 12.56. So take the 16 and subtract the 12.56, and that'll give you 8.44. And so can't be 8. 6, that's 3. 5 minus 2 is 3. 3.44. So you take the 3.44 and divide it by 16, because that's the total amount, and you end up with 21.5%. So what does that tell you here? That no matter how big it was with the circle in the middle, that you end up with the same probability here, 21.5. So like if you go to those carnivals and you see this great big square with a circle, and they ask you to hit maybe the corners of it or something like that, no matter how big it is, your probability of hitting that is going to be 21.5. So don't get pulled in with something like that at a carnival.